In this video, we will use Microsoft Excel to show how to solve the Colebrook equation. As you can see in this formula, it is mathematically impossible to isolate f, which is friction factor. So that we'll be using Excel's goal-seek function to reveal the value of f. In order to do this, you should have some input data. As this session aims to make you understand how to solve it using Excel, we will add random input data for that. Let's say that our initial guess for pipe diameter is 50 mm and the relative roughness is, say, 0.0027 and Reynolds number is 152,000. To predict the friction factor, it would be better to divide the equations into two parts. We can call the left-hand side of the equation as A and right-hand side of the equation as B. And then we will also need another cell for the difference between the left and right-hand side of the equation, which is quite reasonable because if the value of f is found correctly, the left and right-hand side of the equation must be equal. First, let's say the initial value for friction factor is 0.5, and according to this, the left side A is 1.41. And right side B is gonna be 6.246. Yeah, as you can see, the difference between the right and left hand side of the equation is remarkably high. That means the initial friction factor is not correct. We will employ goal-seek function of Excel to carry out automatic iterations and calculate the friction factor for the given parameters. To do this, go to the Data ribbon and What If Analysis. From here, choose Goal-Seek. In this part, we will set the cell of difference to be 0 because we want the difference to be 0, so that we will get the precise friction factor. And we will do it by changing the friction factor cell. Then click OK and wait for the Excel to reveal the friction factor for you. Excellent! For our random input data, the friction factor through a pipe will be 0.02635.